What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm here to drop more math jewels. Today I'm going to be talking about a familiar concept, but I'm going to do my best to break it down as simple as possible. This concept is one that a lot of people look at the formula and they instantly get confused because the way the formula is written. So we're going to talk about slope. All right? Now, slope. Well, what is slope? I'm not talking about the haircut that they used to wear in the 90s. We're actually talking about a concept dealing with lines. And when we look at a line, any line contains several points on it, okay? So every line contains an infinite number of points. So when let's say we have -2 and 5, and then we have 7 and -3. And let's say these two ordered pairs are on the same line. Well, the slope between any 2 points on a line is always going to be the same. So we're going to first of all look at the formula used to find the slope of a line. So the formula is m equals y sub 2 minus y1 over x2 minus x1. Somebody's looking at that right now and they're like, what in the world is that? Why does he have variables and numbers together? Well, these are called subscripts. Okay, so that's a subscript, that's a subscript. And y, they're variables. M is actually the variable that they use to represent slope. Okay, so anytime you see the variable m in a linear relationship, typically it's used to represent the value of the slope of the line. So what this is simply every ordered pair has an x coordinate and a y coordinate, okay? So when we look at this formula, let's say here I have x and I have y, I have x and I have y, okay? So I have two ordered pairs. They both have an x coordinate and a y coordinate. Well, this 2 represents the y coordinate from the second ordered pair. So this is going to be y2. This represents the y coordinate from the first ordered pair. So this is going to be y1. This is the x coordinate from the second ordered pair. And this is the x coordinate from the first ordered pair. So x2 is going to be here, and then x1 is going to be here. Now these are interchangeable. I can say this is x1 and y1, and this is x2 and y2 as well, because the slope between any 2 points on a line is going to be the same. All right. But the thing you must remember is that if you use this first ordered pair as x1, you have to use this as y1. Same thing goes for this. If you use this for x2, this has to be y2. All right. So now that we've identified our x1, y1, x2, y2, all we have to do is substitute those values into this formula. And really all that the slope is it's also known as the rate of change, but it's just a ratio of the vertical change compared to the horizontal change. Okay. So watch, let's get into it. So here, my y2 coordinate is -3, or as I like to say, -3, all right, minus y1 is 5, okay, over x2 is 7 minus -2. All right, so we're going to do the calculations there. Whenever I have -3 or -3 and I take away 5, I actually am getting smaller. So I end up with -8, all right? And then if I have 7 minus -2, remember, whenever you subtract the negative value, it's the same thing as adding. So this actually, I like to do it like this. I say same, change, opposite. Some people say keep, change, flip. I've even heard people say keep, change, change. That means that you keep the first number. This stays the same. We change subtraction to addition. So I'm just going to say boop. And then we change the negative to a positive. So this is 7 plus 2, which gives us 9. So the slope of a line containing this ordered pair as well as this ordered pair is -8 over 9. And because that slope is negative, I know that this line slants downward from left to right. Whenever you have a negative slope, the line slants downward from left to right. So it looks almost like this. Now, we're not sure how steep that line is, but I do know it slants downward. So this is what a line looks like with negative slope. All right, let's go ahead and write the word out. Negative slope. All right. Now, if I have a line with a positive slope, it actually looks like this. It slants upward from left to right. So positive slope. All right. Now, that's just the basics of the slope formula. And like I said, many textbooks still show the term slope and they show the formula and things like that. However, with the Common Core curriculum, they're actually wanting teachers to teach it as rate of change so that you can apply it in real life. Okay. So, for example, you can compare the rate of change of distance compared to the time. So, for example, as a person is walking, they want to compare the distance that they are walking to the time that they are walking. All right. So that slope, once again, my name is Dana Harris with Young Gurus Math Tutoring, and I've got the solution to your math problems.